Hello, I'm Satish Singhal. In this video, I would like to talk to you about pointers to objects. Pointers can also store address of objects, just like they can store address of primitives or natives. They can also store address of objects. First, we are going to show you a simple example using pointer to string data type. First, let me show you a portion of code in Visual Studio and see how it works. Then same code is shown in slides, and we'll walk through that code using the pictures and code right here in the PowerPoint. So first, let's look at the code in Visual Studio. Here I declare a string type pointer SPTR, set the value inside it to be 0. Then I declare a string object called name. Inside that I store John Doe, and then I assign to this string pointer the address of string object name, and here I dereference the string pointer SPTR in order to output the name John Doe to console. Meaning of dereference, or putting the asterisk in front of the pointer, is follow the pointer to its pointee, which is name in this case, and when you do cout asterisk SPTR, that means output it to the console. This is already compiled, so let me just run it for you and show you the output is John Doe, and it sure is right here. So basically I'm printing the object name through its pointer. Okay, that's my code. Let's get back to PowerPoint and walk through this entire code. Okay, this was my code here, and this amber band shows the line of code I'm executing. So in the first line, I declare a string pointer SPTR, set it to 0. So inside my RAM, this is my RAM cloud, I create a string type pointer SPTR and store 0 in it. 0 is also sometimes called null, so I'm storing null inside that pointer. Null pointer does not point to anywhere. It's not a dangling pointer, but it's still an orphan pointer. Then as soon as this line is executed, I'm creating an object, a string object inside my RAM. It has a string John Doe stored in it. Name of the object is name. Its address is 1000. However, as you know, a string is an object that has member functions also. Okay? In this case, we are only showing one of the member function, which is called length. In case of a string object, the length member function simply returns the number of characters in this string that is stored inside the string object. So in this case, John Doe has 8 characters, including this space. Space is also returned by the length function. Okay, so basically meaning of this statement is that, okay, create a string object called name inside which John Doe is stored, and of course a string object has a length function, and the address of this entire string object is 1000. As soon as I execute this line means that store the address of object name, which is 1000, inside the string pointer SPTR. As soon as that happens, SPTR becomes a pointer to pointee name. Name is this object. It has a length function. part of the object. It has John Doe stored in it. SPTR is now pointer to name, so there is a pointer-pointee relationship established as soon as this statement here is executed. When we execute this statement, meaning of this is follow the pointer to its pointee and print the data contents of pointee of SPTR to console. Address 1000 stored here. Follow the pointer to the pointee. Grab the data member. Print to the console. Okay? That's the meaning of this line here. Dereferencing SPTR means follow the pointer to the pointee. Point is this. Grab hold of the data member. Since we have a cout here, output that to the console. Okay? So far so good. Up to this point, the pointer to object did not behave differently from pointers to primitives, pointer to int or pointer to double. The behavior is identical. This is going to change slightly when I invoke member function length through a pointer. Let's take a look at that. Member access mechanism. Okay. Now you know that for objects the member access is done using the dot operator. Okay. If we have a struct, we can create instance of a struct, and if we put a dot operator after the instance, we can access the members. That's how for objects member access is done. Now a string class has a member function called length, and this function when invoked with the string name returns the number of characters in that string. Using the object name, which is a string type, this one right here, I can invoke the length function in this manner. This will basically return the length of John space Doe, which is 8 characters. Function length returns number of characters in this string called name. When you use a pointer to object for member selection inside the object, we need to follow two-step process. This two-step process is very important. Please understand this, pay attention to this, and understand it thoroughly. First, we dereference the pointer using the asterisk operator as below. So this is the step number 1. I have the pointer name, I put an asterisk in front of it. This assembly here inside the parenthesis becomes the alias for the object name. So this behaves just like this thing name behaves. Okay, so this is an alias for the object instance name. Then we use the dot operator for member selection as below. So this, since this is the alias for the object or instance name, I can put the dot here and call the member function length. Okay, so this will invoke the public member function called length. Okay, now in this syntax that I'm showing here, parenthesis, asterisk, SPTR, parenthesis closed, dot length, the parentheses are required to force the dereferencing prior to the member selection. If I don't use parentheses, I'll have a huge problem because dot operator has a higher precedence than the asterisk operator, and then my length function will not get called because I don't even have my object that should call it. Okay, so these parentheses, this one and this one, are required before member selection. Okay, let me go back to Visual Studio and show you a little bit more code to see how I can print number of characters in John Doe to the console, and then we'll get back to here in order to dissect this code further. So let me comment out these two lines here first and compile and run the program again for us to look at it. Notice what we did printed here. John Doe came from here when we are printing the contents of the string. Then cout number of characters in John Doe is equal to 8. So basically it's this part of the statement that gives us value of 8. So pointer SPTR is following, means follow the pointer to its pointee, which is the object name, invoke the length function, which basically counts the number of characters in the string and returns that as an integer. So 1, 2, 3, 4, 5, 6, 7, 8. So length function invoked using alias for the object, which is asterisk SPTR, returns a value of 8, and that value of 8 is printed here. Okay, let me go back to PowerPoint and we'll dissect this code. When we invoke this line of the code, what that means is follow the pointer to its pointee and then invoke the length member function through the pointer SPTR. Address stored is 1000. Follow the pointer to pointee, which is this object. Then invoke the length function, which is this thing over here. And then second part is output the result to the console. So length function will basically count the number of characters in this string here, which is 8, and it's going to print that 8 to the console. Okay, once again, this thing here is the alias. Dereference value of the pointer is the alias for the object. This is my object. Okay, asterisk SPTR is another name for this object called name. There is another technique to do the member selection through the pointer, which is called an arrow operator. Okay, we showed you how to use this technique for member selection through a pointer. This syntax, which uses the dot operator, although familiar to you because you have used the dot operator before, it's a bit complicated because it requires some extra typing. In order to make life simpler, C++ allows an arrow operator for selecting the member of an object, and thus we can rewrite this whole statement like this: SPTR, which is the pointer name, arrow, and the member selection, which is invoking the length member function. This is equivalent to this. Both are equivalent. You can use either one, whichever one you like. General consensus is that this is more convenient, so people use this more often, but it's perfectly justifiable to use this one if this is the one you are more comfortable with. Now I'm more comfortable with this. In the beginning I was more comfortable with this one, but I can use either one now. And same thing with you. This is more common. However, if you are more comfortable with this one, keep using this one. You need to understand that arrow operator is just a convenient way to select a member inside the object. SPTR arrow length does not mean that SPTR points to member called length. That's not the meaning. The only meaning you have here is that SPTR arrow length is a shorthand for asterisk SPTR dot length, and it means nothing else. There is no extra meaning whatsoever attached to SPTR arrow length. It's only a shorthand. It's only a shorthand for dereference value of the pointer SPTR dot length. Okay, so just remember that. So I can use this arrow operator also for member selection, and let me show you example of that. Let's go back to Visual Studio again. And let me comment out the second portion here. And let me compile it again. Compiling is a little slow when I make these movies because the movie making process takes a lot of RAM. That slows down the whole process. And notice that when I use SPTR arrow length, that also prints 8. Asterisk SPTR dot length prints 8. SPTR arrow length also prints 8. So this and this are exactly equivalent to each other. Okay. So if I execute this statement, that means exactly the same thing as this one does. Follow the pointer to its pointee, invoke the length function, whatever the result is, count the character in this one, print that to console, and this also prints 8 as a result. Okay, this is how you can invoke member functions through the pointer to an object. This is how you can do member selection in an object through pointer to the object. We're going to show you another example using the student struct. Here, as you know, all the members in the struct are publics. There's a struct called student. It has two members, name and a double type GPA. Inside the main function, I'm going to have this code: declare student std, a pointer to student struct stdptr, create a pointer-pointee relationship, change the name from nothing to this, change the GPA, print the name, print the GPA. Okay, it's going to take me a couple of seconds to get the code compiled again. Let me do that. Okay, let's see this code in Visual Studio. I declare a student object. This is my struct student. Create a pointer to it. Have pointer stdptr store the address of this student object. Set the name field of this student object to Marido. Set the GPA field set to 3.8. Then through the pointer, I print the name field, which should be Marido, and through the pointer I print GPA field, which should be 3.8. If I run this program, it should print Marido space 3.8, and actually it does. So everything works fine. Let's look at that in Visual Studio, in PowerPoint, and do the code walkthrough. Okay, this is my code. So when I execute this line, I'm simply creating an object std which is of type student. So these three things happen. In the RAM, it creates an instance of std of struct type student. This is my object being created in the RAM. It has an address of 1000. Okay. Now the name field is set to a 0 length string, so name field has nothing in it. GPA is set to an undefined value, so that's why we have these question marks here. The reason name field is set to a zero length string is because when the object is created through a hidden default constructor, this constructor of string class is invoked automatically, which sets the name field, which is string type, to a zero length string. Okay, that's what happens. So this is state of my object when this statement is executed. Here I'm creating a pointer of student type, which is called stdptr, storing 0 in it. stdptr, a pointer storing 0 in it. It's not pointing to anything at this point. It's not a dangling pointer, but it's an orphan pointer. Now I remove the orphanness of stdptr because I make it store the address of std. Address of std was 1000. As soon as I make this assignment, stdptr pointer stores 1000, the address of object std. This becomes pointer to this pointee, so pointer-pointee relationship is set, and now this pointer stdptr, since it has a pointee which is called std, we can do something with it. We can have the indirect access to the name and GPA through the pointer stdptr. Next line, stdptr arrow name equal to Mary-Do. Meaning of that is follow the pointer stdptr to its pointee, which is std, and get write access to the name field of pointee. Store address is 1000, follow the pointer to the pointee, address 1000, which is std. Grab the name field, which didn't have anything earlier. In that, store Mary-Do. Assign the name field to a new value called Mary-Do. That's the meaning of this statement here. Earlier there was, if you remember previously, there was zero length string here. This assignment replaces the zero length string with Mary-Do. The alternate syntax for this line is that you replace left hand side with this. Okay, that's the non-arrow syntax. In next line we do something identical. std arrow GPA equal to 3.8. Follow the pointer stdptr to its pointee, which is std. Get write access to the GPA field and assign, okay, not to the name field but to the GPA field, a value of 3.8. So this is obviously an error here. Assign to the GPA field a new value of 3.8. Okay, and the alternate syntax for this side here is asterisk stdptr.gpa. So you can use either this one or this one on left hand side. It'll be identical thing. Okay, next line. Next is we are outputting name and GPA to the console. So this portion means follow the pointer stdptr to its pointee std, grab hold of the name field and also the GPA field and print both of them to console like this. So this part prints Mary-Do to console, this part prints GPA to console. Output on the console is this, which you saw earlier. And alternate syntax for this entire line will be this, where I use not arrow operator but asterisk stdptr dot name and asterisk stdptr dot GPA. Okay, so please understand both these syntax properly. You can use either one. As long as you are comfortable in using either one, everything is okay. So here's the summary. Object can also be assigned pointers to hold their address. Pointers to objects can get read and write access to public members, which could be data members and public member functions. And there are two syntaxes that are used. Either you can put an asterisk in front of the pointer name, which means dereference the pointer, then dot member name, do the member selection by putting the member name, or you can use pointer arrow member name, which is a shorthand for this dot operator notation. Both syntaxes are equivalent. Second one is just more convenient. Okay? Hopefully you have understood how to access members inside an object, public members inside an object, whether they are data members or functions, through the pointer to the object using either this syntax or this one. Thank you very much.